Good day. In our last video, we did our micro FPV drone build of the 2.5-inch Armattan Tadpole. If you missed it, make sure to check it out through a link in the video description below. It was a simple 10-step build, packed full of extra build tips, a flight stack wiring diagram, and more good stuff. Today we're going to finish up our micro FPV drone build of the Tadpole by binding the receiver, completing the Betaflight setup to include the Tadpole's final tune, which you can download the pin and filter settings template for in the video description below, and we'll take her out for a short flight. Sound good? Then make sure to give this video a thumbs up below and subscribe to your TMac FPV channel, your home for your journey to better FPV fun, flights, and racing stuff. Alright, before we go into Betaflight and do our setup, we need to make sure that our receiver on our Tadpole is bound to our transmitter. And with TBS Crossfire, it's really simple. If you're not familiar with Crossfire, I've got a video on TBS Crossfire you can check out here. First thing we need to do is go into our model that we've already set up in our transmitter and page up to where we normally bind the quadcopter. Here's where we can change the internal multi-protocol module to various protocols. We're not going to do that. We're going to have our internal RF mode off, and we're going to have our external RF mode set to Crossfire. Then to bind our receiver to the transmitter, actually the TBS Crossfire module, we plug the quadcopter in, and we're doing all of this with our props off for safety reasons. I've got the quadcopter setting on its side so that you can actually see the receiver. Currently it's blinking in green. We're going to press this Systems button once, get into our Crossfire configuration, hit Crossfire TX Lite, and we're going to go to Bind. Now when I press this Bind button and go through the menu items, watch how this receiver blinks differently. It says Binding. Now it's blinking red. Do we want to update the micro receiver? Yes. We hit Return, or we hit Enter. It's updating the receiver. It went to solid green. Notice I don't have to mess around with holding in a bind button at the same time when I'm plugging in the battery and pressing the transmitter button. Crossfire takes care of all that for you. You get the display here that says it's updating the receiver and the progress of the percentage that it's updated. And when it completes, watch these LED lights over here. 99, 100%. It's loading, it's blinking now, rapidly. Binding is okay. We're good to go. So we just exit out of here by pressing Return. Return again. And our receiver is now bound to our transmitter. Simple as that. Unplug the quad. And now we're ready to set up the quad in Betaflight. Alright, the first thing we're going to do is connect our quad to Betaflight. And make sure it's sitting level on a flat surface. And then we're going to calibrate our accelerometer. Move just a little bit. Next thing we're going to do is go to our CLI and type in the words dump all and save whatever is currently on our flight controller as its original settings. So all this stuff that's scrolling on our screen, we're just going to copy and paste to a text file and save it as a text file or as a Word document on a folder which we've previously created on our hard drive. So I just go here and highlight all of this, copy and paste it into a Word file, and save it to my computer. And this is just in case we need to revert back to this, back to the original settings that were on the flight controller. We also take notice that the board name or our target name is Betaflight F411, and it currently has Betaflight version 4.1.1 on it, dated November 15th, 2019. We're going to upgrade that to Betaflight 4.2 here in just a little bit. Betaflight F411. We need to remember that. We're going to copy this and we're going to paste it to a Word file, change the font color so I can see it, and save it to a folder which I've previously made on our hard drive named Tadpole. Original CLI dump Tadpole Beta FPV all in one board, Betaflight 4.1.1. Save that, and now we've got that as a backup if we need to revert back to the original settings on our flight controller for Betaflight version 4.1.1, we just copy and paste these back into the CLI and hit return. So now we go back over here and we click on Update Firmware. We are using Configurator 10.7. We want Beta FPV F411 right here. Click on that. 4.2 dated 6/14/2020. We're going to load firmware online, and then we're going to flash firmware. And it failed, which means we need to run the Impulse RC driver fixer. It's installing the DFU driver. Outstanding. Now we go back here and we've already loaded our firmware online. So now we want to flash the firmware. It's erasing what's on there, which we have saved to a file because we did that previously. And now it's flashing the firmware. And programming is successful. That's a good thing. So now we want to connect. We have this notice which states there are custom defaults for this board available, and normally a board will not work properly unless custom defaults are applied. Do you want to apply the custom defaults for this board? Well, yes. If a board will not work properly unless custom defaults are applied, then yes, we want to apply custom defaults. The following problems with your configuration were detected. We need to calibrate the accelerometer. So let's go ahead and do that. Calibrate, and there we have that. And now we go to our Ports tab, and based on the wiring diagram which we did last week, we want to set up our TBS Crossfire Nano on UART1 serial RX, which we have. So we toggle on serial RX, and remember we connected our ESC Nano VTX to UART2, and our ESC Nano VTX uses IRC Tramp. So we go over here to VTX IRC Tramp, and we click Save and Reboot. So our Ports tab is now set up. Now we go to the Video Transmitter tab, and we want to load the IRC Tramp VTX table from File, which I've previously saved on my computer. So we load from File, and I grab the IRC Tramp file I've previously saved here to my VTX tables folder. I load that. We want to set this on Fat Shark 4, and we want to click Save. So we click Save, and we should be good to go on our VTX tab. Alright, our next step in the process is to go to our Configuration tab, and we are going to set our quadcopter's motors up to spin in the reverse direction. And what that does is it keeps debris from getting in front of the camera. It also, when we reverse the motors this way, it prevents the quadcopter from actually grabbing onto branches or things that might get in our way while we're flying. So it has the tendency of not catching things in the props if we reverse the motors. So we're going to reverse the motors. We're going to set this to DShot 300. We're going to keep it at 8K and 4K. We're going to switch our arming to 180, which will allow us to arm the quad no matter at what angle it's at. The reason we want to do that is if it gets stuck at an angle up at the top of a tree or a building or something like that, we want to be able to arm it, try to shake it loose by using our right stick to roll and pitch the quad to try and loosen it from wherever it's stuck at. And hopefully we can get it back that way. If we had this at the default value of 25, if the quadcopter was at an angle greater than 25, it would not arm and we would not be able to try and shake it loose from wherever it's at. Personalization, I'm going to call this TMac FPV Tadpole. We want to set our receiver at serial based and not S-bus. We've got a Crossfire in here, so we're going to go down to CRSF for Crossfire. We want to make sure telemetry's enabled. We're going to set this to toggle that on, and our beacon tone is going to be at 3. You can pick whichever one you want. I know the tone that I like the best happens to be 3. And this will beep when the aux channel is set for it to beep, and we'll go over that in the Modes tab. I'll just keep all these on. Now over here, we're going to come back and set our bidirectional DShot after we upload what's called JESC firmware to our 4-in-1 ESC. For now, we'll leave this alone, and we'll come back to it. So at this point, we'll just click Save and Reboot. In order to set up our bidirectional DShot, we need to upload special firmware to our ESCs, which is either JESC firmware or Jazz Maverick. I prefer JESC. Before we do that, though, that's also where we're going to change our motor, any motor directions if they need to be changed. For instance, just because I've got this toggled on, these are the way the motors are supposed to spin with this toggled on. If I click on this again, they'll spin the other way. See? But these are the ways they're supposed to spin with this toggled on. That doesn't necessarily mean the motors are spinning that way. So we need to check out the direction of the motors spinning, and we'll do that in the Motors tab. And if we need to change any of them, then when we go to the JESC firmware, we can make those changes with the JESC configurator. So prior to toggling on bidirectional DShot, we're going to upload our JESC firmware using the JESC configurator. And prior to doing that, we're going to check our motor directions to see if we need to make any changes while we're in the JESC configurator. So let's go to the Motors tab. All right, now we're going to go to our Motors tab before we go to our JESC configurator. And what we're looking for in the Motors tab are two things. We want to make sure that when we raise this Motor 1 tab, that Motor 1 is the correct one that actually spins. Same thing for Motors 2, 3, and 4. If we lift this Motor 1 tab up and Motor 1 is not the motor that's spinning, it's one of these other motors, that means we need to remap our pins that are associated with the motors to the correct motor. So the first thing we're going to check for is that the correct motor spins when we move one of these tabs up. The second thing we're going to do is to check the spin direction of the motors to make sure that they match this configuration up here for our reversed motor spin configuration. When we enable the motors to spin in Betaflight, it's actually hard to see the direction that the motors are spinning. So there's two ways that you can figure out what direction they're actually spinning. You can hold your fingers lightly on the motor. Don't hold them too hard that they don't spin, but hold your fingers lightly on the motor and you can actually feel the direction that they're spinning. Or what I've done here is I've just wrapped some masking tape, or in this case aluminum tape, around the motor shafts, and you can hold your finger against it and you can feel and see the direction that the piece of tape is actually hitting your fingers, and then match it up with this diagram up here. And if they're spinning in accordance with this diagram, we don't need to do anything in our ESC configurator, whether that's BLLES or JESC. However, if they're spinning in the opposite direction, when we get into our configurator, then we'll just toggle the reverse motor direction in the configurator so that they do spin the correct direction. So right now, let's just go ahead and make sure that Motor 1 spins when we lift the Motor 1 tab. Same thing for Motor 2, 3, and 4. And we do that by connecting the battery to the quadcopter with the props off. And we toggle on this button over here that says I understand the risks, and the props are removed. Then we take the Motor 1 tab and we're watching for Motor 1 to spin. And it does. Motor 2, good. Motor 3, good. And Motor 4, good. That means we don't need to remap any of the pins for the motors using our resource command in CLI, which is one of the useful CLI commands that are identified in this video on Betaflight useful CLI commands. Let's go ahead now and check the direction that the motors are spinning. So Motor 1 should spin counterclockwise. And it is. Motor 2 should be spinning clockwise. It's not, it's spinning counterclockwise. So Motor 2 we need to change in our configurator. Motor 3 needs to be spinning clockwise. And it's not, it's spinning counterclockwise. And Motor 4 should be spinning counterclockwise. And it is. So motors 2 and 3 we need to switch the direction of in our JESC configurator. Let's go ahead and do that, and at the same time we're going to the JESC configurator to enable bidirectional DShot as well as our RPM filtering. I've got a video on the benefits of RPM filters, which you can check out here. And when we upload our firmware to our ESCs using the JESC firmware, we're going to use 48 kilohertz PWM, which is one of the advantages of using it, which will give these small motors up to 30% more flight time with a 48 kilohertz PWM JESC firmware. If you're interested in the JESC firmware, got a link to it down in the video description below. Let's go there now. Since we know our ESCs are BL Heli S ESCs on this Beta FPV Toothpick F4 all-in-one flight controller, that means in order to get bidirectional DShot and enable RPM filters, we either need to use the JESC firmware or the Jazz Maverick firmware. I prefer JESC. So we go to our jflight.net site and we purchase the JESC firmware ×4 for our 4-in-1 ESC, just like you would make any other online purchase. I'm going to add it to the cart, pay using PayPal, and confirm my order. Then back on the main site for jflight.net, we go to our install instructions, and it explains how to go ahead and do this process. You can download and install the JESC configurator by clicking here, which I've already done previously. And this brings up the JESC configurator. Alright, now that we've downloaded our JESC configurator, we've opened it up, we connect our quadcopter to the computer. Over here we make sure that it's on the correct COM port, press the connect button, and at this point we plug in the LiPo to our quadcopter with the props off. And we click Read Setup. And then we've got this green bar up here with a note in it saying our ESCs are unlicensed. We purchased the license, we just haven't licensed them yet over here. We may flash and run JESC without a license using Flash All, but we should consider purchasing the license on jflight.net to enable RPM filters. And once again, when we do the 48 kilohertz PWM, that should give us up to an additional 30% flight time. All right, now we're going to click License All. I've got 4 licenses available since we just purchased them. I'm going to activate the ESCs. We're going to select Flash All, and the JESC version I'm going to use for our 2.5-inch build with 1106 motors, which are smaller motors than what are usually used for the 3 inches and up. So I'm going to use 48 kilohertz PWM version, which should actually give us up to 30% more flight time. Then I click Flash, and then it should go through each one of these ESCs in succession and flash the firmware to each one. Alright, now remember it says don't forget to flash the telemetry service using Flash All Telemetry in order to enable bidirectional DShot for RPM filtering. So that's what we're going to do now. We're going to select Flash All Telemetry, DShot Telemetry Service 2.3, which is required for JESC 2.3, and we're going to select Flash. Alright, now that we've got the JESC firmware and the telemetry activated and licensed and all that stuff, remember we checked the motor spin direction in our Motors tab of Betaflight, and we need to change the direction of motors 2 and 3. We do that by this motor direction tab over here, and on motor 2 we're going to say reversed, and on motor 3 we're going to say reversed. And then we're going to say right setup. Now up here in this black tab, in this black bar, it says finished. I'm going to leave all of these common parameters at their default values. So at this point we're done with JESC, and we just click on disconnect. And you'll notice we've got a new tune on our Tadpole. Alright, now that we've got JESC firmware on our ESCs, we can go back to our configuration tab. And over here is where we want to turn on our bidirectional DShot now, which it states is required for RPM filtering using one of these configurators. And we chose to use JESC. So we're going to toggle this on. Now when we do this, notice this other option comes up here. Number of motor poles, which are the number of magnets on the motor bell. This is important to get this right. Now we can actually physically count the number of magnets on the motor bell by turning the motor upside down and looking at them, or the easier way, which I've found, is just Google the type of motor that you have. In my case, it's the Emax 1106 4500 kV motor. Scroll down into the specs, and this number right here, 9NP12, this number 12 is the number of magnets on the motor bell. So we just take that number, or you can count these little flat things on the outside of the motor bell, and those are your magnets as well. It's just easier, I think, to go to this number and identify, in my case, for these 1106 4500 kV Emax motors, I've got 12 magnets. So we go back to Betaflight and we change this number to 12. That's the only thing we needed to do extra on our configuration tab for our motors. Click save and reboot. Now one thing I do want to check is the direction of our motors spinning. So I go back down to the motors tab and go through this process that we did earlier, plugging in the LiPo battery. And spinning the motors. We changed the directions on motors 2 and 3. So now I want to make sure that motor 2 is in fact spinning clockwise, which it is, and motor 3 is in fact spinning clockwise, which it is. So all our motors are spinning the proper direction. Also, what we want to do is this E is the error rate of the telemetry link for our ESCs. When we spin them up using this master slider, we want that to be 0. If it's anything other than 0, then we've got an issue that we need to stop and resolve before we do anything else. In our case, everything's good, so we're good to move on. Alright, at this point we're ready to move on to our power and battery tab, and normally what I do is just keep these things at their default values. If we wanted to set up our voltage meter, if we wanted to calibrate our voltage meter and amperage meter, to see how to do that process, you can check out this video on calibrating your drone. Then we want to go to our Failsafe tab, and we want to make sure that our stage 2 failsafe procedure is set to drop. As long as I don't have a GPS receiver on the quadcopter and I'm not using GPS rescue as failsafe measure, I'm always going to keep my stage 2 failsafe procedure at drop. And click save and reboot. And then we're ready to go to our PID tuning tab. Here's where we want to reference our tuning guide for micro FPV quads, or our micro FPV drone tuning guide. You can download this guide through a link in the video description below, and the micro FPV tuning guide playlist link is down there as well. We want to specifically go to our tuning guide flowchart, which says that we want to do our filter settings to begin with by enabling RPM filters and adjusting our dynamic notch filter settings. And it gets into specifics on how we do that. So we go to the PID tuning tab, filter settings, and toggle on the RPM filter. Let's go ahead and do that. Filter settings, we toggle on the RPM filter. Leave this at 3 and 100, 3 and 100. Then we're going to change our dynamic notch filter settings to 0, and I'm going to select 200 here, 100 and 200. So we're going to go 0, 200, 100, and 200. And if you're not familiar with what these values are, just hover your mouse cursor over these question marks and it'll explain it all to you. We want to keep the sliders for both the gyro filter multiplier and D-term filter multiplier at 1 for our maiden flight, and then after the initial flight and checking our motor temperatures with these settings, we can possibly move the sliders to the right 1 notch at a time and subsequently perform other test flights to check the motor temps. And if the motors are still cool enough, that will have reduced some of the delay inherent in filtering. For now, we're just going to leave these at their default values. Click save. And then also on our micro FPV tuning guide talks about high authority quads in the 2 to 3 inch realm and low authority quads, and such as whoops. Since we're in the 2 to 3 inch range for Betaflight 4.2 and the high authority quads, in fact, our little tadpole here has got a thrust to weight ratio of about 8, then we want to follow this right hand side of this chart on our micro FPV tuning guide. So we want to decrease P, I, and D by about 70 or 80%. So we're going to toggle off D-min under the PID controller settings, toggle this off, and then we're going to move the master multiplier slider to the left to 0.7 to 0.8. For our tadpole's thrust to weight ratio of approximately 8, I'm going to choose the 0.8 number, and then we're going to click save. So we're going to go over here, master multiplier slider, I'm going to move this down to 0.8, and you'll notice these numbers all went down, which is what we talked about here, moving the PI and D values down per the Betaflight notes for high authority quads. So that's exactly what we did when we moved this master multiplier slider to the left to 0.8. The PI and D values went down, as did the feed forward, so we might want to adjust that later after we do our observations from our maiden flight. But at this point, we want to click Save. And then with these values of our PID and filter settings, we can take her out on our maiden flight and do our observations to see how she performs. Those were our initial filter settings for our baseline tune. Following the flow chart from our micro FPV tuning guide and doing the observations step, both visually through the goggles and also through Blackbox, I've adjusted the filters to these values. First of all, I increased the dynamic notch max hertz to 375 to take care of some motor noise up around the 350 hertz range. And secondly, I was able to move the gyro and D-term low pass filter settings from their default value of 1 over 1 notch to 1.1 to help reduce a little bit of the delay that I was experiencing. And those were the default PID settings for our baseline tune. And once again, doing the observation step of our tuning guide flowchart, both visually through the goggles and also through Blackbox, I was able to adjust the PIDs to the following. I increased the PD balance slider to 1.5, which increases the D-term gain to take care of both some overshoot that I was experiencing as well as some prop wash vibrations. And I've also increased the feed forward through the stick response gain to 1.4. And those are our final PID and filter settings for our 2.5-inch Tadpole. And you can download these final PID and filter settings CLI commands through a link in the video description below, as well as the micro FPV tuning guide. Of course, now we want to go to our receiver tab and make sure all of our channels are working properly when we move our sticks. So when I move the throttle stick, it's working properly, and we want to make sure our endpoints are at 1,000, at or near 1,000 at a minimum, and 2,000 at a maximum, which they are, and about 1,500 in the middle, which you can see from the pitch and yaw and the roll. So let's do roll. Good. Pitch. Good. And yaw. Good. One thing to note with TBS Crossfire, we don't need to use a separate aux channel to get our link quality through TBS Crossfire. So we leave this disabled in our receiver tab. We also just want to make sure that in the configuration tab, we've got this toggled off. So that's it for our receiver tab. All right, now we're ready to go to our modes tab. Since I've set up the Tadpole model in my transmitter with these different mixes on my mixes page, you see I've got ARM on switch F using channel 5, which is aux 1. So I go over here to the ARM option and I add range and I select aux 1. And when that switch is all the way up, this marker will go underneath this bar and be activated. I've got my modes on another switch, switch C, on aux 2. So I click aux 2 for angle, and then I go down here to acro trainer, and when it's in the middle position, I'm in acro trainer mode. And then when I'm flying acro, which is almost 100% of the time, unless I'm doing something specifically teaching somebody through acro trainer, if it's not in the angle mode here or in the acro trainer mode here, then this marker will be over here somewhere, which means it'll automatically be in acro mode when I've got that mode switch all the way up. The next one is our beeper, which is on aux 3, add range, aux 3, and when the switch is all the way up, marker will be over here and it'll be activated. And then we've got launch, which is down here on aux 4, and I've got that in the all the way up position as well. VTX pit is going to be on aux 7, which is actually one of my 6 position buttons at the top of the transmitter. And Blackbox I've got on a switch G, which is aux 8, so that my flash memory will not get filled up every time I fly the quad. It's only going to record my flight data on the black box chip when I've got this switch activated. The rates and the OSD are not in the Modes tab, they're actually in the Adjustments tab, so we'll go there next. And we'll put rates on aux 5 and OSD on aux 6. For now, under Modes, we click Save. It's saved over here, and we go to Adjustments. And we put rates on, I've got 3 different rates, low, medium, and high, and I've got 3 different OSD profiles. So I'm going to put rates on aux 5 and OSD on aux 6. And we go over here and do the same thing. 5, 5, 5, 6, 6, 6. This is going to be rate profile, rate profile, and rate profile. And this is going to be OSD, OSD profile, and OSD profile. And we click Save. Saved over here. We've already looked at our motors. We've already done our video transmitter earlier, so now we're at OSD, and I want to see my battery voltage on all 3, and normally I put that down in the lower right. I want to put the craft name up top. I want to put the link quality in the top right. For OSD profile 2, which we have to change to C, I use stick displays. So if you're not familiar with these different OSD profiles, I put these on a switch like we did through the Adjustments tab, and then I can select what view I want to see in my goggles. OSD view 1, 2, or 3. When I move my switch to the middle position for my OSD profile 2, I'm going to see my stick displays. If I'm in OSD profile selection 1 or 3, they're not selected for 1 and 3, so I'm not going to see them there. I also want to see my flight time, and I want to see my VTX channel. Then we click Save. The only tab we have left is our Blackbox tab, and here I'm going to select onboard flash, which is our onboard flash memory chip, or the Blackbox chip. I'm going to keep it at 1 kilohertz, and for the Blackbox debug mode I'm going to use gyro underline scaled, which is our raw gyro prior to going into any Betaflight filters. Per our micro FPV tuning guide playlist, we want to compare this raw gyro signal to our filtered gyro signal to make sure that our filter settings are actually doing their job. So with that, we want to click Save and Reboot. And for now, we're done with our Betaflight setup. We'll take her out for a maiden flight and see how she performs, and come back and do any necessary tuning based on our observations per our micro FPV tuning guide. It's fly time. that wraps up our micro FPV drone build of the Armattan 2.5-inch Tadpole. She's a feisty little frog and has quickly become one of my favorites. Let me know in the comments below what you thought of this short 2-video micro FPV drone build series, and if you'd like to see more of these, or if you have some other content in mind. I'm always open to your suggestions, and I'm happy to help you on your journey to better FPV fun. Thanks for your time. I'll see you next video. Clear skies, friend.